I am Kirtana and today I am presenting our work titled A Quantum Inspired Firefly Neural Network Decision Model for Multi-Factor Authentication Using Behavioral Biometrics. So the problem statement of our project is today most of us rely on smartphones for banking, personal data and secure authentication system, but the common authentication methods like we use password or pins are actually quite weak, and they can be easily guessed, stolen and observed through attacks such as shoulder surfing, brute force and etc., and even credential theft. Even biometrics fingerprint can be spoofed, and it can be used and misused, where these times we need a secure and intelligent authentication system. So our proposed approach is a multi-factor authentication system using a fingerprint, a pattern and a pin with keystroke dynamics. And our idea is to solve this by using a multi-factor authentication, where we use something you are the fingerprint and something we know the pin or a pattern, and something you do, that is we calculate the user's typing behavior. The third factor, the behavior, is what makes our system more intelligent. We use keystroke dynamics, which means we analyze how the user types, not just what they type. And the objective of this our project is to develop a secure multi-factor authentication system which integrates the 3-layer fingerprint, pattern and pin with behavioral biometrics to make sure it is lightweight and has real-time performance. The key contribution of our work is the use of QIF-NN model, that is quantum inspired Firefly neural network model. Now instead of using a heavy deep learning model, we use a lightweight similarity based approach which compares the current typing behavior with the stored user behavior and checks whether it matches or not. So this is our architecture diagram, where the user initially where the user have to enroll their fingerprint, pattern and password with where it also checks for and calculates the mean flight time and standard deviation flight time. And in first layer, the user gives their fingerprint in there by using biometric prompt API, and then it goes to the next layer, pattern layer, where the pattern and password is encrypted by using SHA 256 algorithm, that is secured hashed algorithm, cryptographic algorithm, to protect the data, making sure the attackers cannot access the their stored data. And pattern authentication is done, and where it checks the rhyming speed and typing, the pattern typing speed. And in password layer, it checks whether the password is correct and whether the user has the same speed, such as the user enrollment. It checks whether the user enrolls when they enroll, that time is there with their this process, where it checks whether it has similar and same time, mean time, standard mean time and mean time, flight time. And after checking all these layers, that is after it passes fingerprint, pattern and pass layer with behavioral biometrics checkings, the access is granted if it passes all the layer. If any one layer fails to enter, then the access is denied to the unauthorized users. So the QIF-NN verifies a behavioral similarity, and final decision will be based on combined authentication results. Proposed methodology: the first process will be data acquisition, where the user enrollment process, we get fingerprint, pattern, pin as a input from the user, and where the keystroke timings, that is flight time, mean time and standard deviation is measured. And in feature extraction, the feature extracted are the three timings, that is flight time, mean flight time, standard deviation. These are the features that are extracted. So like the process is the user verifies in fingerprint, and they enter a pattern, and they enter a pin, and during this step we capture the typing behavior, like timing between key presses. And we implemented this system as an Android application. We used QIF-NN classification, where the behavioral biometrics and the behavioral features are processed and compared with the stored profile using our model. And we have used Euclidean distance based similarity, where it checks whether it passes a threshold or not. And multi-factor decision, after it passes all these layers, the fingerprint pattern and pin behavioral verification, the access is granted. Implementation details, and during acquisition, data acquisition, the user authentication data is collected through a Android mobile application, where the input includes fingerprint, pattern input, pin input, and keystroke dynamics data, that is behavioral features data is captured during the pin and pattern entry. And these pin and pattern data is stored locally using shared preferences in the form of hash credentials, that is SHA 256, and behavioral profile is stored in it. Data pre-processing, these sensitive data are converted into SHA 256 values, where these keystroke timestamps are processed to remove the noise and invalid inputs. So behavioral data is normalized to ensure consistency across the ensures comparable behavioral features for classification. And by storing our data in a SHA 256 algorithm, it is securely stored using hashing technique. This makes the system practical and ready for real world usage. So decision model, these after using QIF-NN model, it checks with the stored user profile and the current behavioral feature vector, and analyzes whether the user is authorized or unauthorized user. So the results and discussion is as where the first fingerprint is analyzed, and then the pattern is checked, and then finally the pin and with behavioral biometrics are checked. And coming to results, this is where our system shows its real strength. Our proposed model achieves 91% accuracy, which is higher than the traditional models. Compared to pin-only systems or dual-factor methods, our approach performs better. It also maintains low false acceptance rate and zero false rejection rate, which means it blocks attackers. It doesn't inconvenience real users. The main reason for the improvement of the behavior biometric is because typing behavior is unique to each person. It is difficult to imitate, and so even if someone who knows your password, they cannot replicate your typing patterns. And this is our performance metrics, where our proposed system have achieved 91% accuracy with 96% precision, 94% recall, and F1 score 95. So advantage of our model is efficiency, and our model is lightweight, fast, and suitable for mobile devices. So we are not just improving security, but also maintaining performance and usability. This system can be applied in mobile in mobile banking, secure login systems, enterprise authentication, anywhere where the security is critical. So, to conclude, we have developed a secure and intelligent multi-factor authentication system that combines biometric, behavioral, and knowledge-based factors. It improves accuracy, enhances security, and remains efficient for real-time applications. Now let's see how our project works. Thank you for your precious time.